Okay, so we're going to transform linear functions. So in lesson 1-8, you guys transformed points. And so you did vertical shifts and horizontal shifts, reflections vertically and horizontally, and stretching horizontally and vertically. And we're going to do all that today, but we're going to do it with lines. So first we have translations and reflections. So let's review them first of all. The translations, we are going to move either left or right. And so a reminder that when we move left, it's going to be this form here. So it's going to be f of x minus h. The value of h is going to be the horizontal change. If h is positive, it's going to move to the right. If h is negative, it'll move to the left. In other words, that will look like this. So if I have f of x plus 4, that's going to move to the left 4, because the value of h here equals negative 4. Right? Because that's why it says minus f of x minus h. If we're adding something on to the end of the function, then it's k, and that means we're doing a vertical translation and move it up or down. Okay. So here's the thing. This affects x, right? And because this is added to the whole function, it affects y, moving up or down. Reflections, if it's horizontal reflection, it affects x. So x is negative. So that means that all the x values are going to be the opposite. So it's a reflection over the y-axis. If it affects the whole thing, negative of the function, that means all the y values are going to change signs. Okay? So any of them that are positive y values become negative y values. So here's a little thing here. It says that to remember the difference between vertical and horizontal translations, think if I add to y, so that would be f of x is another way of saying y. If I add to y, we go high. All right, now we're going up. And if we add to x, we go left. All right, so horizontal. So here we have for example 1. So let g of x be the indicated transformation of f of x. And write the rule for g of x. So we're going to take the function x minus 2, which I have graphed here. F of x equals x minus 2. And we want to do a horizontal translation to the right 3 units. Horizontal translation to the right 3 units. Okay? And here's what happens. So that's a change in x, right? Because we're going to the right. So since it's a change in x, we are looking at this right here, okay? F of x minus h, because we're going to the right. So what's the value of h in this case? 3, okay? So we're going to do f of x minus 3, which means that I'm going to take my original function and I'm going to replace x with x minus 3. So g of x will be equal to f of x minus 3, which means that we're going to take our value x here, here's our x, and we're going to replace it with x minus 3. So we'll have x minus 3 minus 2. We just replaced x here with x minus 3 because it's a horizontal translation. So then we get x minus 5. Okay. So let's think about what that looks like. Okay. If I move this point here, okay, the point at 2, 0, if I move it 3 to the right, I'm going to be over here, right? And if I take the point at 0, negative 2 and move it 3 to the right, then it's going to be there. Okay. And if I draw the line through them, we have, what do you notice about those two lines? They're parallel, so that means they have the same slope. Okay, so the slope was x for our original line, so it's still going to be x for it, 1x. Okay, and our y-intercept is at -5. And so there's our transformation. All right, let's look at this one, letter B. Here they give us a set of points. They want us to do a reflection across the x-axis. So we have two different ways we can do this. We could find the function and then transform it, or we could transform the points and then find the function. All right, so we're going to do part 1 first. So we're going to find the function. F of x equals what? Okay. These are lines, right? So when I write the function then, it's going to be in slope-intercept form. Y equals mx plus b. So what's the y-intercept for this, first of all? What's the y-intercept? These are the same. I just wrote them down here. What's the y-intercept? 1, right? When x is 0, y is 1. That's the y-intercept, is always when x equals 0. So we've got plus 1 here. Okay, what's our slope? Well, let's see. Y is changing by 1 as x is changing by 2. So we have 1/2 x plus 1. Okay. And they want us to do a reflection across the x-axis. So is that y or x? Okay, since it's across the x-axis, it changes the value of y, which means then that g of x is going to equal the opposite of f of x. It's a vertical reflection. Okay, across the x-axis is a vertical reflection. Okay, it's a change in y. So that means I'm taking this whole thing here, and I'm going to do the opposite of it. So we're going to do the opposite of 1/2 x plus 1, and that'll equal -1/2 x minus 1. That's method 1. We can find the function, find the slope and the y-intercept, and then do the transformation. Now the other way we could do it is we could take the points and change them. So if I add a column over here, okay, this would be our g of x, right? y2 or g of x is what, okay? So we are transforming the points first. So we're doing a reflection across the x-axis. So we said all the y values change signs. So what's the opposite of 0? 0. Opposite of -1? Opposite of 1? -1. Opposite of 2? -2. Okay? So g of x equals, it's a line. So we have, what's our y-intercept now? -1. Okay, so we got -1 here. And now what's our slope? Okay, the slope, the y values are going down 1 as the x values are going up 2. So that would be -1/2, right? Which is what we got here. So you could use either method to do it. You could transform the points, find the equation of the line, or find the equation of the line and then transform that. You could do it either way. What's that? This one was way easier? Okay, then use that method. Okay. All right. where you transform the points first. It's actually up to you which method you use. So for letter A, it's a translation 2 units to the right. So that means that h is equal to 2. So to get g of x, we're going to do f of x minus 2, which means I'm replacing the x with x minus 2. So this is going to be 3 times x minus 2. I replaced this x here with x minus 2, then plus 1. So we get 3x minus 6 plus 1, which is 3x minus 5. Okay? So the thing is the lines are parallel, right? Whenever I do a translation, horizontally or vertically, the lines are going to be parallel, so I'm always going to have the same slope. Okay? So you should still have 3x. The only difference is your y-intercept is going to be different. Right, for letter B, reflection across the x-axis again. So we could add to our table here. Across the x-axis, meaning the y values change. So we have -1, -2, and -3. So g of x equals, the y-intercept is where? Okay, when x is 0, so that's -2. And the slope, y is doing what? Going down by 1 as x is going up by 1. So this would be a -1x minus 2, or just -x minus 2. Stretches and compressions. So if I stretch or compress horizontally or vertically, I'm going to change the slope. If I stretch horizontally or compress horizontally, the y-intercept stays the same. Okay? The slope changes, y-intercept stays the same. So if we look here at a horizontal stretch, notice that the slope is going to change, the steepness of the graph changes, but the y-intercept stays the same. Okay, it's in the same spot. Over here, vertical stretch or compression. Okay. The slope changes, it either gets steeper or less steep, and the x-intercept stays the same, or it crosses the x-axis. So there's a couple things to remind you. All right. Now, notice that with a horizontal, we'll say with the vertical stretch, it's going to be a times whatever number this is, or whatever it is. So I'm multiplying the whole y value, or all of the y values, by whatever the transformation is. And for horizontal, though, notice it says 1 over b, okay, which is, what do we call that? If I have 1 over the value, what is that? Okay. It's going to be, what's something when we flip something over, what do we call that? Reciprocal, okay? So when it's horizontal, it's actually going to be the reciprocal is what's going to go in there for x. So b is greater than 1, it stretches it away from the y-axis. If b is between 0 and 1, it compresses it towards the y-axis. For vertical, if a is greater than 1, it stretches it away. A is between 0 and 1, it compresses it towards. So notice something, okay? Look at this. That when b is greater than 1, it stretches it away from the y-axis, okay? Which means it does what? Pulls it this way, right? Okay, away from the y-axis. Right? If it stretches something away from the y-axis, it's actually compressing it towards the x-axis. Okay? And if it compresses it towards the y-axis, that means it's stretching it away from the x-axis. Okay? So those two kind of work hand in hand except for their backwards, opposites. So we're going to let g of x be a horizontal compression of the function negative x plus 4 by a factor of 1/2. So we're going to write the rule for g of x and graph the function. Okay. So first of all, are we talking about A or are we talking about B here? Is this horizontal or vertical, they're telling us? It's horizontal, okay? So that means we're using the value of B. So B equals 1/2. So that means I'm going to do my g of x is going to be f of 1/1/2. Well, all that is the reciprocal. Okay? What's the reciprocal of 1/2? 2/1, which is 2. Okay? So this is going to be f of 2x. So that means I'm going to put 2x in for x. So we have negative 2x plus 4, or negative 2x plus 4. Now let's think about this for a second. Let's graph it. Come on. Here we go. So if I graph this line, okay, y equals negative x plus 4, and it says we're going to compress it horizontally by a factor of 1/2. Okay. Now, that means all the x values are going to be half what they were, right? So what's half of 4? 2. So where I had 4, 0, I'm going to have 2, 0. Okay. What's half of 0? Oh, so the y-intercept isn't going to change, is it? Okay. Let's go over here. What's half of 4? Negative 4. So this point here, which was at negative 4, 8, is going to be at negative 2, 8, because it's half. Now look at the graph that I draw. Okay. What happened to the steepness of that graph? Okay, it grows. Y-intercept is the same, plus 4, plus 4. Okay, let's look at slope. All right. So if we figure out the slope, let's look at this part right here, from here to here. All right. What's my change in y here? That number's 4, right? The change in y is 4, goes down 4, so that's negative, and over to the right 2. What's 4 divided by 2? 2. So there's our negative 2x plus 4. All right, let's see if that's correct. So y equals negative 2x plus 4. Oh, come on. I know it'll do it for me. Delete. Move this down. Y equals negative 2x plus 4. All right. There it is right there in red. Okay? It's right on, yeah, it's right on the other line in red. Okay? So were we right? We were. Okay? Some linear functions involve more than one transformation. So we're going to combine transformations by implying individual transformations one at a time in the order in which they're given. For multiple transformations, create a temporary function such as h of x in example 3 below to represent the first transformation and then transform it to find the combined transformation. So here they said let g of x be a horizontal shift of the function f of x equals 3x, left 6 units, followed by a horizontal stretch by a factor of 4. And write the rule for g of x. Okay? So first thing that we're looking at is we are going to go horizontal shift left 6 units. So we've done 4 letters we've worked with. A, B, H, and K. Does a horizontal shift left 6 units, which of those 4 letters does that involve? Okay. All right, we got a lot of answers. Okay, look at your book. All right, which one is it? It says horizontal shift. Okay, horizontal shift is a change in H. So if we're moving to the left, that means that H is equal to negative 6. Moving to the left is negative, moving to the right is positive. So that means we're going to find the function h of x. Okay, so don't confuse. These are not the same. Okay, this is just the first translation. H of x is a horizontal shift to the left 6. That means we're going to take f of x plus 6. Okay. It's minus x or minus h there, and so we're going to put a negative 6 for h, which makes it x plus 6. So that means we're going to do 3 times the quantity x plus 6. So our first transformation, h of x, will be 3x plus 18. Okay. Slope is the same. Change the y-intercept. Okay. Horizontal and vertical translations. We keep the slope, change the y-intercept. Now, step 2 is we're going to perform the horizontal stretch. So now we're going to do this. Okay, what letter does that go with? A, B, H, or K? Horizontal stretch. B. Okay, and when we use B, we're talking about the reciprocal. Okay, what's the reciprocal of 4? Okay, so B equals 4, so the reciprocal is 1/4. So now to find g of x, we're going to do h of 1/4 x. Okay, because we're putting b in the denominator, right? It's the reciprocal of the value of b is what goes here. So then I'm going to replace this x here, okay, with 1/4 x. So we get 3 times 1/4 x plus 18. Doesn't change the 18. It just changes the slope. So we're going to have 3/4 x plus 18 is what g of x equals. So we translated it horizontally first, and then we stretched it by a factor of 4. Okay. So we could graph it if you wanted to. You don't have to graph it. Okay, it doesn't say to. All right, I'm saying you could graph it, move it over. So just what? Let me do this. All right, so we got 3x. Okay, I can graph that. It's easy. Oops. All right, so here's the graph of 3x. That means, let's see. Oops, hold on. The graph of 3x, the y-intercept is 0, right? Has a slope of 3. No, our original. F of x equals 3x. Okay, I'm graphing the original right now. Okay. The original graph. Oops, that shouldn't be there. It should be there, not there. Okay. So the original graph is here. Okay. Now, we're going to move it 6 units to the left, right? Okay. So I take this graph, and I'm going to move it over here 6 units. Okay. All right. And then it says we're going to do a horizontal stretch by a factor of 4. Well, that means then I'm going to take this -6 and I'm going to multiply it by 4. What do I get when I multiply -6 by 4? -24, right? So that's way out there, okay? But what does that do to my slope of my line? Okay, it makes it only a fourth of what it was, right? Okay. So that's going to take the slope of my line, and I mean, this isn't going to be perfect, but it's going to look something like this. Okay. Obviously, my y-intercept is way off since it's 18. It should be up there somewhere, but do you get the idea? Okay. So you could look at it graphically. You don't have to. Okay. Okay. So find this one. Right. The golf team is selling T-shirts as a fundraiser. All right. Greca, you going out for golf next year? All right. Are you doing shot put and discus? He was? Okay. All right. The function R of n is equal to 7.5n, which means that every time they sell a T-shirt, they get $7.50. Okay? Represents the team's revenue in dollars, and n is the number of T-shirts sold. The team paid $60 for the T-shirts. Write a new function for the team's profit. Okay? They paid $60 for the T-shirts. Is that a plus or a minus? Minus, okay? Does that affect it horizontally, okay, which is the number of shirts sold, or does it affect it vertically, which is the profit? Vertically, okay? So that means I'm going to add it on to the end. So this is profit then is equal to 7.5n minus 60. Okay? Yep. So the y-intercept is going to be -60. All right? That makes sense, right? Okay. All right. And here's the thing. Profit is always revenue minus expenses or minus costs. Okay? My revenue is $7.50. I know. $7.50 a T-shirt, and they had to pay $60 for the T-shirts. Got glue on his arms. Okay. All right. So it says graph them both on the same coordinate plane. All right. So we'll think about them and describe the transformation. What's the transformation that happened? If we graph them both, the graphs will look like so the first graph is going to be here, right? Has a y-intercept of 0. Okay, so we're going to assume we're going to say this is 7.5n. Okay, and then the second graph is going to look like this then. Okay, where this is at -60, right? Okay, so what do we call that? What did we do? Is that a horizontal translation or a vertical translation? Okay. Did I replace? Okay, listen. Okay, now here's the thing. All right, now here's where you need to. Did we replace the x variable, okay, or the independent variable with something, or did we add it on to the end of the whole thing? We added it on. Now, adding it on, is that horizontal or vertical? No. Adding it on is vertical. Changing the independent variable is horizontal. So this is a vertical translation down 60. Okay? All right. Because we're moving the graph down 60 because we went from 0 here to down here to negative 60. That's a vertical shift or vertical translation. Okay? I know. You're going to have to take your time with these.